Okay, so in this video we're going to look at the discriminant of a quadratic equation. This is something you typically learn in about year 10. You know it because of the triangle thing. You know that bigger than 0, less than 0, equal to 0 means something, but let's remind ourselves because often it gets forgotten by year 12. The discriminant determines the number of solutions to a quadratic equation without having to solve. And that's really useful, particularly in an exam or something, when you don't know if you can solve a quadratic, or you're sitting there staring at it, trying to solve it, and it turns out there are no solutions at all. So it's really useful to be able to know how many solutions you should get at the end of the question before you start, which will enable you to save some time and do some checks to make sure you're doing things right. So remember, the discriminant is always given by b squared minus 4ac. And that's all based on having a quadratic equation here equal 0. It must be equal 0 for the a, b, and c in our equations to work. So ax squared plus bx plus c, remember a is your coefficient of x squared, b is your coefficient of x, and c is the constant term. They get substituted into here. I'm not going to show a proof of the discriminant, but this all comes from completing the square on this general format. It's a bit lengthy, a bit technical. I'm not going to go through it now. Now, there are three key results from our discriminant. One is that if it's bigger than 0, the whole equation has two solutions. If it equals 0, the equation has one solution. If it's less than 0, it has no solutions. Now, remember, that was because of the quadratic formula, which is this. This comes up in a different video of solving quadratics. Like that. If you have a number under this square root sign that is negative with the real numbers we're dealing with, you can't get a result for that. So if you have b squared minus 4ac, that just happens to be our discriminant hiding under here. The values. If discriminant is less than 0, then you're square rooting a negative number. Not possible in the real number plane. If the discriminant equals 0, you get square root of 0 under there, and square root of 0 is just 0. And then if you have negative b plus 0 or negative b minus 0, it just gives you the same thing. So you're just left with negative b over 2a. The last one is if it's bigger than 0. If this thing here is larger than 0, then you have a plus and a minus option. You have two solutions. If you sketch it on a graph, the plus one is always the one towards the right of the x-axis, and the negative one is always to the left, as long as you've fully simplified it. Before I show you how to use it and remind you how to use it, the discriminant can also help decide which method you should use to solve a quadratic. That's a different video to solving quadratics, but the discriminant will help you determine which method is best. If you find that the discriminant comes out to be a nice perfect square like 9, or even a fraction of like 9 over 4 or something like that, if that is your discriminant, you know it's under a square root sign. Square root of 9 would be 3. Square root of that is 3 over 2 or something. If you have a perfect square, then it's more than likely that you'll be able to easily factorize the equation and then use a null factor law. If, however, it becomes something without a perfect square, so for example 8, we know that square root of the discriminant will give you square root of 8. Now you probably in that case be thinking quadratic formula is much easier, much quicker, because remember the factorizing thing, you're thinking of two factors that add to this, that multiply to this. You don't want to deal with thirds. But again, solving is for a different video, but the discriminant will help you which one is better to use. So let's use it. Determine the number of solutions to the following equations. There's all sorts of different ways they can ask this. They often ask you to find days of k, so that there are two solutions, but I'm just focusing on how to use the discriminant, and it's basic at the moment. So discriminant, always remember, is b squared. That looks too much like my 6. Minus 4ac. Remember a is the coefficient in front there. B is the 7, the coefficient of the x, and the c is the constant term at the end. So I'm just going to substitute those values in. So you find b is 7 like that. I'll put brackets. It's important because if you have a negative and you square it, you'll get a positive result. There's nothing written in front of the x squared, so it must be a 1. We have 6. So you get 49. 4 times 1 is 4, times by 6 is 24, and you end up with a 25. So that is greater than 0, therefore you have 2 solutions. Now notice in this case, this is a perfect square, which would suggest to me that you can easily factorize this thing for null factor law, which indeed you can. That's x plus 6, x plus 1. So, excuse me, keep that in mind when you're solving quadratics. This next one, you're going to have b squared minus 4ac. Now b is this 9 in this case. Oh, why is that working? So you get 9 squared minus 4 lots of a, which in this case is nothing in front of the x squared, so it's a 1, multiplied by c, the constant at the end. And we're going to simplify. So 81, 4 times 1 is 4, times 5 is 20, and that gives you 61. Again, it's greater than 0, so therefore you get 2 solutions. In this case, if I put 61 under a square root sign, you can't simplify that. 61 is not a perfect square, so in this case you would need to complete the square and solve, or use a quadratic formula to solve a quadratic equation if this was equals 0. Which of course is not right now, but if it was, that's what you'd be thinking. Next couple, discriminant again is b, so it's going to be negative 9 and squared. So negative b squared minus 4 times a times c. A is the coefficient x squared again, c is the end, and we're going to simplify all of that. 4 times 2 is 8, times 4 is 32, and that gives you 49. Again, 2 solutions. Hopefully I have one here where it doesn't work out nicely soon. That's the way it goes though. Again, this has a square root, so you would factorize this one. And we continue on. So b in this case is 2 minus 4 times a, negative 3, and c is 1. This one's a bit different because of a negative here. You've got to be careful about double negatives. So we get 2 squared is 4 minus, now 4 times 3 is 12. 12 times 1 is 12. But you've got negative 3 there and you've got negative 4 there. So together they make a positive, don't they? So you end up with 16. Therefore, 2 solutions. This one again would factorize nicely because 16 is a perfect square. Last 2 examples. B is 6, so it's 6 squared, minus 4 lots of a. A is 5, it's the coefficient out here, times the constant at the end, and hopefully here you can see 6 squared is 36, 4 times 5 is 20, 20 times 10 is 200. Well, we do not get a positive number, therefore no solutions. All right, now final thing. So of course, in this case, if you ask to solve it, you can't solve it. So you're going to have no solutions in the real number plane. The last one, b is 2, a is 7, and c is negative 3. Again, we've got to be careful of negatives in this case, which is why I put this one in. 4 times 7 is 28. 28 times by 3 is 84. Can't remember to do that, of course. Multiply it here. Or you can do 30 times 3 is 90, take away 2 of them and give you 84. And again, we have 2 negatives multiplying, so it gives you positive 84, which gives you 88. Now this thing does not have a square root, so this would be one where you would use a quadratic formula to solve. And that is the discriminant. It's different solutions. Whoops, that has therefore 2 solutions. The only case with 1 solution is when you have a perfect square. So if you had something on the lines of 2x plus 1 squared and that was fully expanded out like this, If you did the discriminant on this thing, you would get 0. You have one solution because it is a perfect square. Everything else would be 2 or 0.